Technically, you can see x can't equal 4 or -3. So your whole is actually at 4. So the issue with me was that when I put my what do you call it? When I put the values into the calculator, I did from both sides, right? Because you're supposed to do a limit from both sides to find out what the actual thing is going to. I had this thing. Okay. Well, okay. 4 minus 3.9 over
Oh, I know.
and then 3.9. So now this would have been fun, but on a scientific calculator, you get to put it in like this.
Hello.
I didn't even have a calculator. No, because I forgot my scientific calculator, right? So he didn't let me use like the actual calculator. It's like,
Yeah, but you're supposed to put it in like this. I forgot this.
Scientific calculator, you mean like TI-84?
No.
no. What? It's like the other version. There's no.
TI-30.
What?
Yeah, I know.
Hey, that's what he makes you use?
Yeah.
Yeah. Oh no, why are we in the 7th grade?
That's not
Get started. It's very tough. I'm sorry for people on Zoom because I don't know how to take off the.
Use a
Thing.
TI-84. It's because
But I'm just gonna go through this quickly and then we're gonna start the
Figure.
test.
It's
Okay?
like goaded.
It's
Yours
yours.
Of course. Yeah. And
That's a good idea. I don't know how to do that though.
TI-84.
Yeah, we're not allowed to use that.
Just let you use it.
Oh.
That's easy teacher.
Yeah, he's not.
Wait.
Genuinely.
Bob started
You're
it.
smart.
So even if you.
I am.
Technically, like
Oh,
all
yeah.
quizzes are like have 20. So if you
Yeah.
score anything above
Yeah.
12 hour days.
So like I used up my bonus points today.
Hello.
I'll do it again.
You are so smart. Okay. Perfect. There is no more echo. We will get started. Okay, so we got orbital energies, right? This is basically. Oh yeah, hi, my name is. So, right? We have all these energy levels, right? 1s2, 2s2, 2p, 3s, 3p, 3g, 4s, 4p, right? That's just kind of how the energy levels is. Remember what I said if you guys came to the last session, right? If you look at the periodic table, right? You can see this like visually on the periodic table. And it's something that you shouldn't really memorize. It's something you should try to understand. But yes, I'm going to continue. Electron screening. This is an important concept, but it's important for the next section. I don't know why Professor Yusuf didn't really like he like kind of.
I got very confused on this.
It's not that much of a. So basically, the bigger the atom, right? Let's say this. Let me take this off real quick. Okay. So the bigger the atom, right? The more poor electrons it has, right? So think of like, I don't even know how to explain this. So if you guys have a periodic table on you, right? Let's just think like, I'm gonna take like for example, I guess like I'm just gonna draw, this is a nucleus, and then this is like principal energy levels, right? The more core electrons like this guy has, right? So like there's so many electrons, right? These are the valence electrons, right? Valence electrons are electrons in the outermost shell, right? So basically these core electrons, right? They're blocking the nuclear charge, right? The positive charge on this, right? And what happens is it decreases the overall effective nuclear charge on the valence electrons, right? So what that means for this is that the electron is easily like you're going to be able to ionize this atom a lot easier. And you're going to see that next lecture when he talks about that. Because yeah. So like if you look at the periodic table, let's see, where do I have the periodic table?
You just passed it.
I just passed it.
Yeah, like
Oh, yes. So like francium. Francium is the lowest ionization energy. And it's no coincidence that it's in the seventh energy level, right? Because it has so many electrons that are just bombarding its it has like what, seven principal energy levels, right? And it just has one electron. Don't worry, you're gonna learn this next class, but basically, yeah, the electron shielding is the reason why it's so easy for francium to lose electron. But don't worry about that. That's for tomorrow. All right. I hope everyone on Zoom is good. Are you drawing on the board because we cannot see? Why can't you not? Oh, it did not show that. That's okay. I'm sorry, guys. Okay, let's continue. Okay, so penetration effect. Honestly, this isn't that crazy of a concept to like fully like understand, but basically penetration is like the opposite of like energy level, like the energy, yeah. So like Professor Yusa said, right? The order of like increasing energy is like indirect proportional with the penetration of like the orbitals. And yeah, it's like it's kind of just like if you know the increasing energy of orbitals, you should know the decreasing penetration effect of orbitals. That's basically how I would memorize that or understand that. But yeah. Does anyone want me to go over this or not? You guys are chilling with this? Okay. But I don't know how to say this, guys. Off. Does anyone know how to say it? Off bow. This is a very self-explanatory concept. It's that the lowest principal energy level is what gets filled first. And we see this on the period, we see this when we're filling up electron shells, especially when we get up to like the 4s, the fourth principal energy level. Because you see how the 4s is a lower energy than 3D? That's what happens. We fill up the 4s or energy level before the 3D. And you'll see that more next class when you talk about, well, no, you know what, we actually did talk about that. It's like chromium and copper, for example, they're exceptions. Why they're exceptions is honestly because they want to satisfy, it's more stable to have a half filled or full filled 3D shell, right? So basically, chromium's thing. I show the chromium. How many electrons does chromium have? I don't know. Let's go back to, okay, chromium, right? Chromium is, how many electrons does chromium have, guys? You guys know how many electrons? 24, yes, CR, 24, right? So to write this wave mechanical model, right? Can anyone tell me what to write or not?
1s2,
Okay, 1s2,
2s2,
2s2,
2p6,
2p6,
3s2,
3s2,
3p6,
3p6.
4s1,
Ooh, yes, good. And then?
3, 5.
Yes, 3D5, right? So what that means, what is happening is the S or electron, right, is moving to the 3D5 electron. And this should make a little more sense with Hund's rule. But basically, if I were to draw the orbital out, this would be the S orbital, right? One thing, right? As that's how it would normally be if there was a 2 and then this was a 4, right? And then how this would look like is 1, 2, 3, right? It would be like this, right? It's more stable if this electron goes over here and then fills that. And that's what happens in nature. So the reality is, yeah, for these things, it would be like that. That's the only exception to that. Copper is the same thing. Anything in the copper group. So copper is right here, copper there. And its thing is that now it's 4s1, 3D 10. And it does the same thing, except now it fills this one. All right. Does anyone have any questions about this? Okay, that's the only exception to the rule. And it's the same kind of thing where it wants to fill up, it wants to stabilize the higher energy orbital. All right. I need to get my eraser. Or else I'm gonna get cancer. I'm joking. I don't know if it's carcinogens and expo markers. Does anyone know that? Is it carcinogens, expo markers?
Not anymore.
Not anymore. Oh shoot.
I think like the really old markers they used to use were actually bad for you.
Really?
I think so.
Like smell or like if you touch them?
I love smelling
Both.
expo markers.
I believe.
Expo marker smells great. How's everyone on Zoom doing? Can you guys see everything? I hope you guys are good. I can't hear you guys. So if you guys could text in the chat that you guys are okay, that'll make me feel good. Okay. So yes. Hund's rule. Hund's rule is that yes, degenerate orbitals will get filled up and unpaired electrons will have the same spin, right? That's what I was saying with the nitrogen example, right? Nitrogen, has 7 electrons, right? 1s2, 2s2, 2p3, right? With electrons, with the p orbital, right? If I were to draw out all the stuff, right, this would be 1, 2. This is 1, 2, right? This is the 2, this is 1s, this is 2s, right? 2p would be like this. That's the rule with Hund's rule, right? Unpaired electrons will have the same spin. So if you were to ask quantum numbers for this, right, you would have to make sure that you specify one specific spin. Don't just say plus or minus 1/2. You know, you would say like, you do like n equals 2, l equals 1, ml equals -1, 0, 1, and then you would do ms equals like plus or minus 1/2. Does anyone understand that? All right, cool. Okay, moving on. Yay, I'm glad that you guys are good. Okay. So moving on. Yeah, this is like a good way to memorize understand the orbital if you write it out like this. You guys are never gonna go beyond like the F block. It would be very rare for him. It would be a very mean question for him to go to the F block. But when I say the F block, I mean like the 4F range, because that's a very high electron range. But yeah. All right, are you guys all chilling? You guys have any questions or comments, concerns? Thoughts about life? No? Okay, so that's what I was trying to show you on Monday, the relationship. So if you just look left to right, you can count out everything. 1s2, 2s2, 2p6, 3s2, 3p6, right? That's how I like memorized it or understood it. Because yeah, the periodic table is not just a collection of random elements. Yeah. Does anyone have any questions about the exceptions? Anything about that? Copper and the copper group, all of these guys right here, copper and I did not copper and chromium. All right. Does anyone have any questions about that? Yeah.
So just that entire group also has the same.
Yes. So silver would have it. The modi, I don't know how to say that. I know how. I don't know how to say that one.
Moldy.
Tungsten would have that. Gold would have that if they were to ask that. So it's very important that you guys just catch that when you see that. And you guys have the periodic table. So you guys should be able to catch that. Just think copper group or chromium, and then you could. Yeah. Okay. That's the lecture, guys. So I'm going to give you guys a practice test. Everyone on Zoom, I emailed this to you guys. So I'm just going to go through this because I tried to, it's not laid out, I guess, kind of like a test. So basically, I kind of like randomly put like a bunch of like free response questions and like questions like, yeah, that you would see at the end of the test. It's not laid out like your test. But it should help. It's about module 3 and module 1. I missed module 2 because I'm gonna do that before a side session on Monday, yeah. So I will hand these out to you all. You guys can cheat, because I don't care if you cheat. I would like you not to cheat. Okay, you guys can do whatever the heck you want. But yeah, take this like you're taking the real. That's smart.
What do you constitute as cheating?
Don't ask. Don't ask me. I'm your SI.
Says the guy that tells us that we can use a calculator, put in words and stuff.
I didn't say
Oh,
that.
you got it.
Don't do that. Because
I
then-
mean, recorded?
Oh yeah, it's recorded. Yeah, it's recorded.
Do you post the recordings?
I do. I did last session. Yeah.
Oh.
And I started doing them. But you guys can do that on Zoom. Please open the email and just try to do that. I'm gonna give you guys like some time to do it. How much time do you guys think? There's 39 questions. What do you guys think? 45 minutes? 45 minutes? Is that good? Okay, 45 minutes. I'm gonna give you guys 45 minutes. So I'm going to put a timer on. Timer for 45. Okay, stop recording.
Part over there, we're gonna continue, I want to be there, because I thought I was supposed to go to the 17th. Larger.
Timer, 45. I'll do 44 minutes now. Alright. There's some typos on there because I forgot to add grammar. If you guys have any questions, let me know. Alright, and. You guys can see that on the screen. So, oh wait, I forgot to say this, guys. At the back of the thing, there's the periodic, everything you're gonna have on the test. So you guys can see that, you guys can practice with it, do whatever the heck you want. Though, Spiro, there is, I think on the back of one of them is the questions for the last page, so just make sure you see that.
Isn't all the noble gases are missing?
What?
The noble gases?
Noble gases? That's the electron negativity
Oh, I'm
values.
blind.
So this is the. So electron negativity, right? You're gonna learn this. Noble gases are inert, so they don't have electron.
Yeah, I forget. I think it was barium. It's not G, is it?
So you're gonna need to know how to memorize this stuff. Barium is there.
It's thanks.
Barium is Ba.
Yeah, I can.
BR is
Hey.
bromine.
Yeah, I know.
B is boron.
Because on the test, they're gonna say barium sulfate. You're gonna need to know barium. You don't need to know sulfate, but you need to know barium.
Oh, Luke, I have another question. If it says, so like, right, the wave mechanic model, can you do the condensed one, or do you have to write them all out? Like, would it specify if you can or can't use the condensed?
Yeah, I would specify. I would say write the whole thing out for practice.
Alright, sounds good.
Long ass model.
I know, that's why I chose it. Okay.
Why do I have to write the entire thing out?
I'll just practice.
It's literally 6S2.
Huh?
It's 6S2, like that's. Yes.
You said this nicer than.
No.
No, I'm sorry.
I'm joking. No.
Can tell you that.
Okay.
No, nothing. Nothing, no.
Luke, I have a question.
Minus one half plus one.
Highlights from my eye, I'm just gonna rinse it out. Oh my god. Okay.
Thank you so much.
No, you're chill. I don't care. You still care. I don't care. I know you. There are 10 minutes remaining. Minutes. Jake, has any dumb mistakes?
For number 35, do we circle more than one? Are we allowed to circle more than one?
The multiple choice question.
So it's only one.
How many multiple choice questions on these tests usually? Do you remember?
Oh, the practice, the test from last year was 35.
You remember?
I have the test from last year, guys. I actually put some questions on there. I'm that
Are
guy.
there short answers or it's just straight multiple choice?
Hey, you guys are still testing. Are you guys done? Are you guys all done? I'll say this at the later. Talk to you next week.
Let's see.
Yeah, you don't need to ask me, guys.
We're treating this like a real test, we gotta ask.
Well, yeah. You're right about that.
Answer one back. Or no, are there answers on here?
I'm gonna go over it. And then, yeah, I'm gonna post
Cause I
them.
got.
Oh, yeah, I go, okay, no problem. Yeah, I'll post them for you guys, so. Don't worry.
Actually, it's just right.
On Monday, I'm gonna do a practice test with you guys. And I'm gonna do maybe like 15 minutes, or like. Yeah. How was the time?
I probably got the nose questions wrong.
It's okay. I mean, you guys probably didn't start studying yet, so.
I also rounded it to 3 times 10 to the 8th, like just be to like whatever. But that's okay. So, wait, we have to sign in?
Yes.
Minutes. I'm gonna stop the timer here, actually.
Because I don't think I'm gonna have enough time to go over this. So for everybody that is on here, I'm going to stop the timer, all right? Just want to, what's it called? Yeah. This should, I mean, honestly, like, kudos, I mean, I think this probably is like one of the first, like, I guess, like, tests that you guys have taken in, you know, it's just. It is what it is, right? I don't know. I think like So for Yusuf's test, you're gonna be able to have the time to finish it like in class. Like you guys, it's 90 minutes and you'll have the time to finish it in class. And yeah, if you guys had like any sort of trouble with this, that's okay. I feel like I'm a little more tougher than Yusuf because I want you guys to be better. Yeah, really, yeah, because I think Yusuf is, yeah, I think that Yusuf is.
I feel like he's tougher by not explaining anything to us.
What do you mean? You don't think he explains anything to you guys? What? Like with what?
Like that's just you.
Maybe it's just me, but I did not understand electron shielding when he explained it.
Electron shield. Do you understand what I said?
Yes.
Okay. Yeah, but yeah, I'm gonna start going over this stuff. So that you all can.
Ask the question now. Did you not?
No.
Well, then you know.
Okay. Let me just screen share this. All right, and regardless of how you guys did, this is like a good indicator. This is me going over this. Is like I guess like kind of explain to you all like how I would approach the problem and how I would like look at the like multiple choice problem and like figure out how to do it. I think like a very important aspect of like taking like of any problem is like the approach, right? Like how do you go from looking at this problem and be like, what the hell, to I know how to answer this, right? A lot of people, I feel like, struggle with that, struggle with like being able to approach a problem correctly. So I'm going to be just going over it. There's an echo again. Are you serious? There's an echo. How is there an echo this time? Oh no. How is there an echo? Not anymore? What?
Trolling you.
I know, they're just trolling me. There's no trolling. I'm not that old. Okay.
I don't understand. You're only 1 year older.
Okay.
Not the first time.
Okay. All right. Okay, guys, calm down. Hold your horses. All right. Where's the marker?
In front of the box.
Okay. So actually, I should write this on the
You're gonna get
iPad.
poisoned from the hand again, remember?
All right, I'll write this on the iPad. So question one. This one is a fairly straightforward one. D orbital. How many orbitals are in D's? D orbital. D. No.
5.
Yep, 5 orbitals, right? So the answer is D, right? Very simple. Okay. How would you identify the last valence electron in nitrogen, right? So nitrogen, right? I keep writing this, but nitrogen's 1s2, 2s2, and 2p3, right? So how would you identify that, right? Remember, it's in the second one and it has the same spin, right? So it's like one of these, right? So process of elimination or just write the numbers yourself out. I feel like writing the numbers out is probably the fastest way to do this one because all the numbers are kind of confusing to look at. But yeah, the answer is D because all these don't make sense. 3, that's not right. 1 is wrong. And then this one is S1, and then this E is the middle one. E is this one. All right. So does everyone understand that? Awesome. Moving on. All right. What are degenerate ovals? You guys just learned this. Does anyone have a good answer for this, or it's kind of something you just kind of know it or you don't?
Hey, right?
Yeah. A. Right. A. They are trolling. Wait, someone said they are trolling. That's funny. Okay, on the chat, but yeah, it's A because hydrogen atoms, right?
It's only for hydrogen, right?
Yeah, only for hydrogen. And other things, the degenerate orbitals are literally like the D, like 3D, like all the orbitals in there are degenerate.
Yeah.
Okay.
But for hydrogen, those orbitals are degenerate. All right. So can anyone well, least to energy to the most energy? I just kind of go down the list, like 1s2, 2s2, wherever.
Yeah.
That's what I do.
1s, 2s,
3P.
3p, 4s, 3d, 4g. Does everyone understand how I got that? All right, it's because if you were to write it all out, it would be, yeah, like that's how the order would be. And then likewise with the penetration thing, it would just be reverse that. So it would be 4d, 3d, 4s, 3p, 2s, 1s. All right, sound good? Yeah.
Why would 3D be before 4S?
Great question. So basically, for 4S, right? If you look at the I guess like the way that the energy levels work, right? 4S has a lower energy than 3D, just because of how it is like.
So it's related to energy, not because on the like the slide it said like it's based on energy level and then inside it was SPDF. That's why I was confused if it was based on energy or not.
Yeah, so it's based off of energy when it comes to what's it called? When it comes to this kind of stuff. So basically, a good way to do it is like the tree thing, right? 2S, 2P, 3S, 3P, 3D, and then 4S, 4P, 4D, 4F, right? Just kind of going across like this helps show like the energy levels, right? So that's like a good little trick for the test to see that. But yeah. All right, true or false? Electron shielding describes the effect when an electron is emitted from a material due to high energy light. That is false, right? We went over that. That what I described there is, do you guys know what that is? What?
Electrical?
Yeah, photoelectric effect. This is the photoelectric effect. Electric effect. I'm gonna make a nice little emoji there. Whoa. Okay. Write the main wave mechanical model of barium. All right. What is this? I don't even know where. Is it xenon? I don't even know.
It's xenon.
It is xenon. That's crazy. Okay. Xenon. And then what's it called? 6S2. You can do the condensed one. I would recommend practicing with the full thing because yeah, I'm just doing it because I don't have time. But yeah, that's basic.
If we have time, can you write out the full thing?
Okay, I mean, I could do 1S2, 2S2, 2P6, 3S2, 3P6, 4S2, 3D10, 4P6, 5S2, 4D10, 5P6, 6S2. Okay, all right, moving on. Let's go. Which scientist found energy levels? Does anyone know?
Or
Bohr! Yes, Neil Bohr. What did Einstein do? What did he do?
photoelectric effect,
Good. What did Millikan do?
charge to mass ratio.
Charge and mass
Oh,
of
charge.
electron. Oil drop experiments, right? What did Max Planck do? Or what did he find?
Quantized energy.
Yes, energy is packets. He found photons, right?
Wait, what did he do? What did he do?
He found that energy was packets, like photons, right? He found that you can quantize energy. Okay? So, when frequency increases, energy.
Increasing.
Yeah, good. That's very good. Okay? So, the thing that is, it's E equals NHV, right? So, when I write it like this, I'm trying to convey that it's a direct relationship. When you see stuff like this, it's a direct relationship. That is a important concept just in general, but yeah. Does anyone have questions about that or not? Okay, good. I know that a lot of people probably didn't know this one.
Oh, yeah.
Which of the following
Yes.
statements regarding the electromagnetic spectrum is true? Does anyone know this?
UV is lower frequency than X-rays.
Yes, you're right. It is that. I don't have it memorized, but I did check that question before I did this so I can look professional. But yes, you just kind of have to know this. It really sucks, but there's gonna be like one question or two questions about this on the test. So that's why I did that. So making sure you guys know that. Okay. True or false? What is it, guys?
False.
Yes. What is this rule? Do you guys know? Hun's rule. Hun's rule. Hun. The Hun. Mongol. Wait, the Mongols. You know, like from Mulan, the Huns, right? Is that what it's called? Yeah, okay, I just wanted to say that. Okay. Well, how many nodes exist in the n equals 4 thing? 3. Yeah!
Can you go over this one? I like forgot to find the
Okay,
notes.
nodes is a very simple concept, right? So nodes equals n minus 1. That's all.
See, I think it was before or 3. I didn't know which one.
Very, very quick. Yes, okay.
Nodes is-
Anybody on Zoom, if you have questions, please let me know.
Oh my god.
Because yeah, I'm here, I wanna help you guys. I love you guys. Okay, moving on. What is the quantum numbers for the 6 electrons in 3p orbital of argon? List all of the quantum numbers, all right? So I'll do them really quickly. I'm not gonna list all of them, but n equals 3, L equals 1, right? Does that make sense for everyone? Okay, ML would equal -1, 0, 1. MS for all of these would be plus or minus 1/2. You just have to list all of them, 6 of them. So, yeah, does anyone have a question about that, or you guys are chilling? All right? Okay, moving on. Suppose an electron moves from the first principal energy level to the fourth. What happens as a result? Anyone know? Yeah, good. So, this is gonna definitely be a question. I pulled this right from the test from last year. I mean, I changed the wording a little bit, but yeah. When energy, like I keep showing this kinetic thing, right? So like, if a ball's dropping, right? This is, let's move this so you guys can see me. So this is potential energy, right? And then when it drops, it becomes kinetic energy, right? In order for the ball, if you want to pick this ball up, it takes energy, right? So same thing with this, electrons, right? When an extra electron drops from the like high energy level to a low one, it releases energy. But when it has to go from a low energy level to a high one, it takes energy. It absorbs energy. So yes, B, photon is absorbed. All right. Okay, moving on.
Wait, you said if it was the opposite, then it would be emitted, not absorbed?
Yes.
Okay, thanks.
Yes. On the test from last year, that's what it was. So, yeah, okay. What is a wave mechanical model for phosphor? Phosphorus. Phosphorus is right under nitrogen. 1s2, 2s2, 3p6, 3s2, 3p3. All right. Everyone know that? Don't worry, you guys don't need to memorize things like me. I just like chemistry. But anyways, let me pull out my wrapping calculator. Okay. I am a very disorganized person in general. You guys will come to know that, but that is what it is. All right, so 6 energy level to the 3rd energy level, right? The thing we're doing is, just let me do that. Oh, fuck. No, what is going on? Wait, okay. Okay, everything's okay. Okay. All right. So this, what you gotta do is you gotta do delta E equals NH. No. The first one, no. Oh wait, I have to do 16. Okay, so this one's E equals -2.178 times 10 to the -18.
Yes.
All right, and then 1/n² final, right?
Yeah.
Minus 1/n² initial. Don't worry, this is on the reference table. So let me do that quickly. So all these calculations, obviously they're big numbers, but once you know how to do it, should be quick, right? Should be fast and quick. Yeah, it's kind of, I know it sounds kind of intimidating, but like like these are the kind of questions you'll see on the test, right? You're gonna see a question like this and you're gonna be intimidated and you're gonna spend 5 minutes on this, but the reality is you just kind of have to put it in the calculator and solve. Know the equation and then yeah.
You just do partial credit, right?
Well, there's sometimes questions like this question that I pulled was a multiple choice. So like there's gonna be multiple choice answers and then you have to pick it and stuff. But on a free response, yeah, it would totally be. Okay. But yeah. 1/0 divided by. So that's 6, so that's 36. Minus 1 minus 1/9. Okay. All right, so what did you guys get?
I got -1.815 10 to the.
Good, okay. Now, this is a little bit of a trick question because I wanted to do this because I don't think Yusuf gets that annoyed about this, but basically when it says that energy is released, you don't want to put negative. The only time you want to put negative is if they ask just for the energy change, but if it says released, because negative means you're releasing energy, right? So you can't like release energy. So I mean, what I always like to do on the test is I always like to write 1.815 times 10 to the -19 joules of energy is released. Like I like to write that as a statement because just so that no confusion is there,
Will he
so.
do something like that?
Hmm?
Will he do something like that?
Probably not. I'm just like that. Joules of energy is released. All right. Okay, now we go to wavelength, right? So you want to take that. You don't want it to be negative, by the way, when you take it to the other equation. And you want to do E
Wait,
equals.
you don't want it to be?
Yeah, you don't want to be negative because energy itself is not negative. The only reason why it's negative in the first one is because of the fact that it's representing that energy is being released.
Oh,
Yeah.
okay.
Because it's going from the sixth to the third, right? So yes, E equals -1.815 times 10 to the -19 joules. But in this one, you want to do positive because that's just the energy in general. Right, equals NHV. N is one, okay? Anytime you do these questions, N equals one, okay? They're never gonna tell you it's not one because this only applies for hydrogen atoms. Okay, so you wanna find the wavelength and you wanna find the frequency. You can do both of these questions, one of them first or the other one. I'll do the wavelength one first, just to speed things along. So you wanna do that, so it would be 1.815 times 10 to the -19 joules, right? And you wanna write it like 1/6.626 times 10 to the -34 joules times second, right? And then times speed of light,
2.9979 times 10 to the 8th meters per second.
it's 2.998. 979?
That's
It
what
says that in the
says it
reference.
there.
Oh, it
That's
says
not
that?
confused, yeah.
79, okay, I'll use that. Times 10 to the 8 meters over second. Gonna do
In
that.
class, but it was just 2.998.
It's 9.9978. 79. So it rounds to 998.
Oh, I should have asked nanometers.
What?
Next time. It's okay. No, it's not that.
I
end
wanted
of
to
the
like
world.
do
I
an
just-
extra conversion for me to say nano.
Ah, hell no.
Yeah.
That's how it's gonna be on the test. They're gonna ask in nanometers. I should have asked that in nanometers. Okay, so I'm getting a little confused with the units, so I'm just gonna do this now.
Yeah, I didn't realize that. I guess it makes sense. You really can't have a negative length, right?
Times 10 to the -19.
Your point off.
Right, you wanna divide Planck's constant, so 1/6.626 times 10 to the -34 joules. Okay. And then you wanna divide.
What?
No, I need to flip this whole thing, this whole expression that
Why
I'm
don't you
putting in.
just multiply all the top
No, I just need to flip it.
and then divide it by.
No, on my calculator, I'm realizing that I'm gonna get 1 over wavelength, so I have to just flip it. What is it called? Times 2.979 times 10 to the 8. Okay, and then you flip this. Okay, I got 1.23 times 10 to the -33. I mean 23. Is that what you guys got?
Wait, you get sorry?
1.23 times 10 to the -23. No, okay.
Well, I think it's because I used a negative, so.
No, I mean the negative should just make the final answer negative, right? I didn't get that.
Okay.
I also forgot how to use this equation, so I did frequency and then I went to
Let's see,
wavelength.
what do you
I
got?
may have done it wrong.
Maybe I'm wrong.
I got 1.094 times. Oh wait, what'd you get? What was your?
I thought the same.
That's me?
Okay, so then you guys are probably right. I probably did it wrong. Yeah, you peruse. Okay.
Wait, what did you get?
1.094 times 10 to the -6 meters.
Okay, let me do this legit.
Yeah, okay.
Yeah, 1.09, will be
Okay, let me do this legitly. Okay,
What?
so.
Last rounded.
Did it?
It's 1.0948, so you round it to 1.095.
It's 1?
Ah,
0.44.
6.626 times 10 to the -34. Second. Okay.
Oh, well,
2.979 times 10 to the 8. Yes, and then
Yeah.
divided by.
I don't know, in class, do you ever do 2.9989, whatever?
Oh, wait, that was supposed to be a 7.
Yeah.
Okay, wait.
Worst of
I feel
habit.
like, yeah,
66 times.
But usually you're using
10 to the
2.9.
negative
998 or.
yeah, that's what that's what I feel like I do.
Yeah, okay, that makes more sense.
Divided by 1.815 times 10 to the.
Supposed to be positive, right?
Yeah, right. Yeah, I know.
Yeah, you can't have a negative distance. That's the important thing. Yeah, I got 1.09 times 10 to the negative 6.
Basically,
You guys got that?
yeah, I got a 4 after the 9, but
4 after 9. Oh, so okay. So you guys good with that? Everyone got that answer? Good. Alright, so 1.0. I'll put 9. B is very lenient when it comes to like
Sig
sig
figs.
figs, so you don't need to worry about that. And it's in meters. He would ask you to write it in nanometers, so that's a little trick if you guys wanna do that. Frequency, very simple. Now you just put C equals lambda V. And you can use meters to do that. So 2.979 times 10 to the 8 divided by this number. And I got 2.74 times 10 to the 14. You guys got that?
that's what it hurt.
Second minus, right?
Is second minus the same thing as hertz? Or-
Yes, it is. I'm just using that. Yeah, it doesn't really matter what you put.
Hertz would have been fine?
Yeah, it would
Alright,
be fine. I'm good. All right, everyone chilling? Okay, I'm chilling. Okay, everyone on Zoom good? I hope you guys are good. Okay, moving on. Electrons, what is this? You guys know?
C, 5.
C, yes, 5.
Can you just go over again how to find the balance?
So valence electrons are very simple. It's literally, what's it called? It's all the electrons on the outermost shell, right? And so there's 7 principal energy levels on the periodic table,
Yeah.
right? If you look at nitrogen, right? Nitrogen, it's like hydrogen, helium, right? And then it's 5 elements, right? So then that means that there's 5 electrons. Okay.
What was it? Sorry.
Yeah, the answer is 5
Okay.
electrons. Yeah. Does everyone understand that? Everyone good with that? Okay, moving on. Who discovered all matter exhibits wave and particle-like properties?
Broccoli.
Broglie. Yeah, good. Alright, beryllium, core electrons. What are core electrons? You guys know?
Is everything except the balance electrons?
Yeah,
Okay, well, I thought about it, but I didn't do the question. I forgot.
it's okay, no worries. So yeah, it'd be n equals 1. It's very simple. It's just like n equals 1, L equals 0, ML equals 0, right? Yeah. Yep, okay. Wait, 1. L equals 1. Sorry, guys. Don't wait.
No, 0.
Yeah, it is 0. My bad, guys.
Beryllium's 4.
Sorry, guys. MS equals plus or minus 1/2. All right, you guys good? Okay. Which of the following, what does line spectra display? Does anyone know?
B.
Yes, good. All right.
For 21, we just have to write out the quantum numbers, right?
Mm-hmm.
Okay.
Yeah. 22, A is continuous line spectra, right? I mean, continuous spectra, right? Over. C and D are a bunch of nonsense. Okay. 23, how would you identify the 4s electron in chromium? And I meant to say in quantum numbers. So,
Oh. So I just like 4 as 1. I didn't know like what to do.
yeah, no, that's my fault. I should have put that in
yeah.
quantum numbers, but
It's a 4, 0, 0, 1/2.
L equals 0, ML equals 0, and then MS equals plus 1/2, because there's only 1 electron in the 4s, right? So it's just plus 1. Okay?
Wait,
What-
I'm confused. For 23,
Yeah.
why did you put L as like 0 instead of like any like or 1 or?
Because it's
Because it's
4.
the 4s.
Oh, duh. Yeah.
Yeah. No worries, guys. No worries. Okay. How many nodes are in this? Anyone shout it out?
4.
4. Yes, good. At what energy level does the H sub-level start? To exist. Does anyone know how to do this one?
Huh?
C.
C. Okay, so the way to express this, right? Who is?
4, 0, 0.
Right?
1/2.
Well, 6.
Positive and negative or?
Positive.
Okay.
So if n equals 6, right? L would have to equal 5, 4, 3. L could equal 5, 4, 3, 2, 1, right? Okay, or 0. No, yeah, wait, yeah, 0. Okay, right? So this is a P1. This is D. Okay, this is F, G, and then this is H. All right, you want me to explain this any further for you guys, or are you guys chilling? This was a question on the test. Except it was like I or something.
Was it really?
Yeah, it was.
It was the I sublevel?
Yeah,
And that would just be 7. And
so yeah, it just increases by 2, right? So yeah, it goes from F and then G, H, I, J, K.
Yeah, I know it's like the alphabet thing.
Yeah,
Alright,
okay?
wait, can I just, I need to just copy in the like.
All right,
Question.
yes.
For 23, right? When you're doing the last one with the spin, how do you know if it's up or down? Or does it not matter?
23?
Because it says the forest electron in chromium,
It
and I
doesn't
know there's
matter,
only
the string
one.
can be plus or like minus, but it has to be just one of them.
Oh, okay.
That's my trick, yeah. Okay, so what is the condensed configuration of chromium? Does anyone know?
Wait, what's the-
Argon, forest,
what's
2,
the
3,
answer?
5.
For 25.
4s2?
Oh, it was 6.
4s1!
I wrote forest 1. I don't know why I saw 2.
It's okay. 4s1, 3d5. I'm sorry, guys, this is like very repetitive because I'm going off just one module. It's not gonna be this like condensed on module 3. I mean, there is a lot of modules. All right, how much energy is absorbed? Okay, this is the same kind of question.
I think this should be right because they're all positive.
Yes, this one,
Oh,
all these,
right.
all these are gonna be positive because it's getting absorbed now, right? Going from first energy to fifth energy. I will go over this. I will just do the problem later for myself and then put on the answer key because I don't want you guys to stay that late. Okay?
I got nothing to do.
No, I gotta go home.
I know it's dark outside, guys. All right, so
Wait.
wait, but this question, as energy decreases, I should put an S here. Wavelength increases. Good, very good. That's a good relationship to know. Okay. All right, moving on. Okay, this is now module 1. Sounds very quick and simple. Okay. The true value of the measurement, whatever, right? What is the right answer? Does anyone know?
B.
Yeah, B is right. Good. Accurate would be closer to the value. And yeah, so there's gonna be a question like that, definitely. Okay, what does a quantitative measurement consist of, guys? What did you guys put for this?
Let's see.
Yeah, you put C?
Because I initially put D, but then I said it doesn't.
So this is the one question I got wrong on this test. And it's C. I put B because I thought, I don't know, this is.
So it's C.
The answer is C?
The answer is C.
Okay.
Darn it.
You know, I was gonna put precision, but I'm like, if you
I know, it's one of the-
one number, then you can't be precise because you don't exactly know.
Yeah, I don't really like this test that much because it's not a lot of chemistry. That's my thing, but that's beside the point. Which of the following is a state of matter that does not have a volume and conforms to the shape of a container?
Gas.
Yes, gas is correct, right? Gas, like think of the room, right? The gas is taking up this whole room. You could also put it in a gas tank and it's the same thing, you know? Like that's a good way to think about it. All right, which of the following has the least number of sig figs?
E.
Yes, how many sig figs does that have?
2.
Good, very good. Which of the following is an extensive property?
Mass. C.
Yes, all these are intensive properties. Intensive properties mean that no matter what you change, it stays the same, you know? I kept saying in the beginning, but if I cut my hand, I'm still me. You know, I'm still me, so that's good. All right, which of the following mixtures are heterogeneous?
Yeah.
Okay, okay, so mud is heterogeneous. I hope you guys just know that. Because yeah, water doesn't mix with that. Sand is mixture of oil and that's it. All right,
Okay, wait. So I got it right. Can you explain why sand is heterogeneous?
because it's not just like sand is not just like a bunch of little like it's a bunch of different little things in it. There's different rocks, different materials in it. It's like that you can if you looked at sand from a cross-sectional thing, it would be like a bunch of different like dots and like you might see like a shell in there or something like that.
Like sand, it's like a bunch of like different piece of rock color, you know, it's all like different, right?
Glass would be a homogeneous mixture. Glass is SiO2. So that's just a fun fact I know. Okay. What is the well-tested hypothesis that describes a phenomenon?
Okay, that's wrong. I said theory.
It is theory. Good job. A law is something that is a observable thing in nature, I guess.
Laws can change, right?
Laws cannot change. Laws are fine, like grounded in
Laws can't change.
laws can't change.
Like, I feel
Scientific
like-
law, not American law.
I feel like in the active,
Oh, really? Maybe laws can change. I might be wrong about that. but, okay.
If you-
That's why I got it on like more times and I finally clicked it. I feel like I thought like laws can be like disproven and changed.
I guess not as easily as theories.
Just know the definition. That's beyond my scope. Okay, no, I'm just kidding. You can ask me everything. Okay, but yeah, I'll look into that for you.
Alright,
Does everyone know how to do this one? Do you know the conversion from micrometers to kilometers?
I know.
No, but I just did dimensional analysis.
Good, good. Dimensional analysis is a very important skill. I'll just show the dimensional analysis really quick. So micrometers, right? How many micrometers are in a meter, guys? You know?
10 to 6.
Yes.
Oh, it's 6, that's been now.
So
10 to 9 is
for every
Nano.
1 meter, or every 1 meter, there is 10⁶ micrometers. Okay? For every, how many meters are in a kilometer?
1000.
Yes, 1 km, 1000. Put this in the calculator, you get the right answer. What is the volume of a substance with a density of that, and then,
I got P.
Yeah,
Mass.
good negative.
you guys know how to do this one?
I think so.
4.4 ml.
I mean, I didn't get the answer, but
Alright.
V equals M over V, and that's it. Alright. I will post the answers for this on, I'll send you guys it. I will be a little more. I'll send one email instead of 3. I'm sorry for spamming you guys with emails today.
Yeah, I was like, oh, but I mean, there's enough.
I forgot to put the Zoom link.
I know.
So I'm really sorry about that, guys. I'm here for you guys. If you have any questions, comments, concerns, please let me know. I'm here to help you guys. Anything about life as well, just in general, I don't
Wait,
really
so you
care.
never answered a question from before. Does he do short answers?
Does he give you short answer? Yeah.
He did answer it.
Oh, he did?
I think like make the question, right?
And then you're just like locked in, bro. You don't even.
No, I don't.
Yeah, but
Alright, thanks, Luke. I'll probably see you tomorrow around
Yeah.
the school.
Monday, I'm gonna do a practice test. So
It's like another one of these, but like all modular.
yeah, the whole module. I'm gonna literally use Yusuf's thing and then like change it up a little bit. You guys come for that.
He's still supposed to practice.
They'll post it tomorrow. If you guys have any questions, let me know. Get home safe, guys.
I feel way better about this than bio.
I'm doing good, doing good. This week was a little busy, but I've been like locking in. I'm almost done with all my week's work, so that's good. What's that?
An orbit test.
I had an orbit test Monday. Very.
Thanks, Luke. See you later.
See ya. See ya. Yeah. We have a teacher for Orgo that has like an accent, so it's kind of tough to understand her sometimes, but it's okay.
Alright, see you later.
Don't do that though. Take it one and done.
I mean, if
Yeah,
you
you
have
have multiple, so basically,
For third year.
yeah, so before, for you guys, it'll be January 2027, right? Yes, so before January 2027, you have to get the right required MCAT score. You guys don't know it yet, I think you guys are, ours is
So
507. So,
for the,
yeah, but
so you have to match this in the score of the incoming
yeah, but
class.
honestly, guys, like, that score is not like terribly hard to get. If you look at the MCAT and look at how you actually like how it scores and stuff like that. So if you guys are worried about that, obviously let me know. I'm not studying for it yet, but
Okay,
I'll start
that's the
studying
next
for it.
question.
I'll probably start studying for it next semester. That's why I'm not gonna be your Chem SI next semester, probably.
Is there gonna be one next semester?
No, probably not. I mean, it depends, maybe.
Who teaches Gen Chem 2?
Yusuf.
Oh,
I would do it, but I'm gonna have, it's my second semester, so. Yeah,
that's
I'll
fair.
see. Yeah. Yeah, Mhm.
So even if it's 6, like it was YP, it would still be M
yeah, that's just how they pick you up a bit. Yeah, you guys chilling?
Yeah.
Alright, get home safe, guys.
You too.
Bye. See you later. Hey, wait, why is everyone still here on the Zoom? You guys can go. Hello? Why is everyone still here?
Wait, quick question.
I can't
Does
hear you
this
straight
start at
if you're
5?
talking. But have a good day. Have a good day. I appreciate you guys staying here. I'll just say, you guys, and does this start at 5 or 5:30? 5:30. It started at 5:30. And it ends at 7. It's just the test ended long. Do you guys have any questions or comments, concerns? I can't hear you guys, so just type it in the chat. Bye. Bye, Nishi. Have a good day. I hope you guys Do well. I'll see you tomorrow. Oh, it's just me now. Okay.